This is project 29 of Hacking with Swift. We're going to remake a classic MS-DOS game from way back in 1991. It was the fantastic way for kids to waste time during computer classes at school, if you're my age that is, and the game is called Gorillas. You're going to learn lots more, of course. I use these projects, as you remember, to sort of squeeze Swift knowledge into you with ulterior plans. And this time you'll learn about texture atlases, scene transitions, how to mix UIKit with SpriteKit, and also destructible terrain. Literally terrain that gets destroyed over time. In our case, by monkeys flinging bananas, as you do. For more information, see the website hackingwithswift.com, where you can buy this video and all videos in this series in fabulous high resolution or as downloadable ebooks containing stacks more technical information to help push your Swift learning into fast forward. Alternatively, find me on Twitter. I am @2straws. If you have questions, suggestions, feedback, whatever, follow me there. Get in touch. I would love to hear from you. Go ahead and launch Xcode. Then choose Create Project and select iOS Application Game. Next, I'll call mine Project 29. Please select iPad for device and SpriteKit and Swift. Then Next and Create. Please do the usual cleaning project we do with these things. So go into the Images Assets folder, zap the spaceship, go into GameScene.swift, take out the code from inside did move to view, and the code from inside touches began. You should also make the project lock to landscape only. So deselect portrait and upside down. And download the files for this project from hackingwithswift.com. Here they are here. But don't just go ahead and copy in this content folder just yet. We'll do that later. For now, please just copy in helper.swift so we can make stuff with it. Copy items if needed, create groups, yes, awesome, and continue. Remember, for SpriteKit projects, I do recommend not using the iPad Air simulator, but instead using the iPad 2 simulator. You'll get much higher frame rates. Okay, we're going to start by making the game environment. If you've never played Gorillas before, the game environment is a nighttime, high-rise skyscraper scene on which there's two gorillas. In our case, we'll use monkeys because I can't find a decent public domain picture of gorillas. And they throw bananas to and from their building until one of them hits the other gorilla to win. So we're going to use core graphics. I am sure you remember all that wonderful core graphics work we did in Project 27. It's time to put it into action by drawing the buildings using core graphics. I should make you aware ahead of time, I have taken the colors and broad layout of the game from the original MS-DOS game Gorillas. It may look terrible, but that's the way it's designed to look. I'm not just a terrible designer, even though I am a fairly terrible designer. It is designed to look this way because we're trying to clone a retro game. So right click on Project 29, the folder, the yellow thing, and choose New File. Select iOS Source, then Cocoa Touch Class, and click Next. For its subclass of, enter SK Sprite node, and name the thing Building node. Like that. Press Next, and then Create. It will immediately start complaining because SK Sprite node is not recognized. You have to actually add the import SpriteKit for you up here at the top, like that, so it'll compile correctly. So to begin with, this class will have three methods. Firstly, setup. This will do the basic work to make this thing a building. Its name, its texture, its physics. If you recall, we don't, if possible, override the Swift initializers because they do create a fair amount of extra work. So we want to add a new method called setup that does all the work for us. Another one called configure physics that will do per pixel physics for the sprite's current texture. And then a third one saying draw building that will do the core graphics rendering of our building and return it as a UI image. Now the phrasing of those things are very precise. There is a sprite's current texture, which means it will change over time, i.e. as bits get blown off by those exploding bananas I mentioned. To make this work, we have to keep a copy of the building's texture as a UI image so we can modify it later. So let's create a property now to hold the current image. So var current image is a UI image. We'll store in there the current building image that's been drawn, so we can modify it and modify it and modify it as bits get blown off. So the setup method's quite simple. Func setup, name the thing as a building, so we know what we're looking at. And then we want to also call the as yet unwritten draw building method. So we'll say current image equals draw building, passing in size. Size is a property of Sprite node that will tell us how big the sprite node is. And then set our texture to be a new texture from that image. Image, UI image, we'll do current image. Oops, current image. Like that. And we'll call configure physics, which again we haven't written yet. So there's two methods here outstanding. Configure physics is quite straightforward, so we'll do that first. So func configure physics. We want to do physics body equals sk physics body texture is our texture. Oh, source code has crashed. Thanks Xcode. Texture is texture, and size is size, like that. Source code's figured out again. Good. Then we'll say it's not dynamic. So self physics body dot dynamic is false. Then self physics body dot category bit mask. Now we're going to assign these in just a second. So the bit mask we'll use is called collision types dot building dot raw value, and then we want to say self dot physics body dot contact test bit mask, which collisions we want to be notified about, equals collision types dot banana dot raw value, like that. So we are a building and we care about when we collide with a banana. Let's go ahead and define this collision types thing now. It's an enum. And as you can see, we're using the raw value as we've done before in previous projects. So go ahead and go to gamescene.swift, and before the class definition, let's create the new enum. So enum collision types. It's a uint 32, but you must specify this if you want to have raw values behind it. And we want to have three things: case banana is 1, case building is 2, and case player equals 4. Remember, these numbers here should be powers of 2. So let's recap just briefly. This will draw the building. I haven't actually made that method yet. It'll assign it to be an SK texture from that picture that was drawn and configure its physics around that using these things here. This thing is a separate method configure physics, not in here directly, because we want to be able to configure the physics later on. It is warning me because it doesn't like collection types. Of course it doesn't like collection types. Collision types. There we go. Oops, collision types. Boom. So all that remains now is this missing draw building method. Now this is not terrifically complicated, but hopefully you have read and done well with Project 27. First, it needs to create a new core graphics context the size of our building. Then fill it with a rectangle that's one of 3 colors, just like the DOS game. Then draw building windows all over the building in one of 2 colors, either yellow where there's a light on, or grey where there's no light on. And then pull out the result as a UI image and return it for use elsewhere, i.e. here. To make things slightly more interesting, I'll show you a different way of creating colors. This is very popular with designers, this one. It's called hue, saturation, and brightness, HSB. This takes 3 parameters, 0 and 1 each. So 0 to 1 hue, 0 to 1 saturation, 0 to 1 brightness. Brightness, of course, is how bright the thing is. Saturation is 0 gray, 1 is pure color. Hue is like a color wheel, like choosing a color inside OS X, where it's a wheel, so it goes round and round and round. So 0 is red and 1 is red, with all other possible hues in between. One of the reasons HSB is very popular is because if you want to make pastel colors of a matching pastel, you can use the same saturation and brightness and just change the hue and just whiz through all the possible pastels at that sort of shade very, very quickly and easily. Anyway, we're going to use HSB here. I've sampled the colors from the DOS game, so we'll get very close to that, and we can do all this inside the draw building method. So let's say func draw building. This takes a size to draw at, so we'll say size is CG size. And returns a UI image. So first, UI graphics begin image context with options. Size, false 0, that's old news. Then get reference to the context, UI graphics, get current context, again old news. Now we're going to draw the rectangle for the building. Now this, like I said, this has to be done at one of 3 different colors, but the rectangle itself is the same, so we can declare that up front. So let rectangle equals CGRect. It wants an X, which is 0, Y is 0, width is width is size.width, and height is size.height. That's being passed in by this parameter here. Then let's make a new color. Var color is a UI color. And we'll fill it in with one of 3 values. So we'll do switch random int min2 min 0 max 2. In case 0, the first color will say color equals UI color with the initializer hue, saturation, brightness, alpha. So hue is 0.502, saturation is 0.98, brightness is 0.67, alpha is 1. You're welcome to try and guess what color that is, but I think it's fairly unlikely. I will then have case 1 with color being hue 0.999, saturation 0.99, and then brightness 0.67. And finally, default, not case 2, it must have an exhaustive switch case. This time the hue is going to be 0, 0. Saturation is going to be 0 again, and brightness 0.67 again. So we've got 3 colors here, sort of a bluey green color, which is this first one, a reddish color here, and then a gray color. So 3 different building colors. We'll then make that our fill color by doing CG context set fill color with color, context, and then color.cg color. And add that as a rect to our fill, to our path, sorry. So CG add rect, context, and then rectangle, and draw that path. Draw path, context, CG path fill. There is no stroke, but of course you can go ahead and add that if you want to. The code's all there for you to extend. Now let's fill the whole thing with lights. The buildings will be a fixed number of widths. There's not too much variety, it's not fully random widths. So drawing windows is quite straightforward. First we'll define 2 colors up front. So we'll say let light on color equals UI color. This one's a hue of 0.190, a saturation of 0.67, and a brightness of 0.99, alpha 1. And then let light off color is UI color, hue 0, saturation 0, brightness 0.34, alpha 1. And now we're going to loop through rows and columns, drawing windows across the way like this, down the way, randomly on or off. So for var row, which must be a CG float, it's how to draw things inside core graphics, equals 10. Row is less than size dot height minus 10. So there's a bit of padding either side, 10 points of padding either side. Row plus equals 40. Then for var col, again CG float, equals 10, again padding it in. Col is less than size dot width minus 10. Col plus equals to 40, like that. So we're creating windows across the X and Y. Now, is it lit or not? So I'm going to say if random int 0, 1 is 0, then we'll say the light is on. So CG context set fill color with color, context, and the color is light on color.cg color. Else, CG context set fill color with color, context, light off color dot CG color. All this, by the way, is old news to you. You've done this before again and again and again. This is not anything surprising here. Okay, so now once we know which light color to draw, we just draw the right one. So we'll do CG context. Let's do this to something different this time. Let's do fill rect, context, and the rect is CG rect with col for the X position. Y position should be row. Width should be 15, height equals 20, so long, thin windows. After this loop here, we're going to yoink out the image from the context. So we'll say let img equals UI graphics, get image from current image context. Then end the context to free up the RAM and so forth, end image context like that, and return the image like that. Boom. That's it. None of that is new apart from this HSBA stuff for your hue, saturation, brightness. In fact, actually, I think KCG path fill is new, but it's just that rather than fill stroke. So you should be able to look at that code and recognize I'm drawing rectangles in two different ways. You can choose whichever one works best for you, whether you want to use fill rect or add rect then draw path. Knock yourself out, it's down to you, it's your code to modify all you want to. Choose the one that looks nicest to you and use it. Now that is the building node class finished for now. We're going to return to it much later to add a method to be called when it gets hit by a banana. But for now we're done, so please go back to gamescene.swift. We've got a small amount of work to do here in order to use these building nodes to build the night sky scene. First, we want an array of all the buildings. The reason for this is because we want to be able to add a monkey to the second building and one from the second from last building. Not the first and last building because it looks a bit strange. Second building and second from last looks much nicer. And the easiest way of doing that is having an array of buildings and just picking out the second and second from last. So var buildings equals an array of building node, and just create it like that. And inside the move to view method, we want to give our scene this night sky color, which has been sampled from the MS-DOS game. So we'll say background color equals UI color. Again, use HSB. Hue is 0.669, saturation 0.99, brightness 0.67, alpha 1. And we'll call a method called create buildings, which I haven't written just yet. So this is the important one here. Obviously, that's doing all the work. And that one method will finish our background scene. So it's going to have to start on the left-hand side of the screen here and then move across, adding buildings, adding buildings, adding buildings till it hits the edge of the screen, at which point it stops. Now I'm going to make it start at -15, so it looks like the buildings carry on going to the left. They don't start at the very left edge of the screen, which would look quite strange. I'm also going to add a 2-point gap between the buildings so you can see the edges of them more clearly. Now the buildings are going to be a random size. For the height, it'll be truly random, between 300 and 600 points high. For the width, it needs to divide evenly by 40, so our window drawing code is nice and simple. So we'll generate a random number between 2 and 4, and then multiply that by 40, meaning we either have 80, 120, or 160 points wide. So the way we're creating buildings, again, is by not using a initializer. If you look at the node here, we're not overriding the Swift initializer. We're having a setup method called later that draws a texture and adds it in. So what we're going to do is we're going to create each of these buildings with a flat red rectangle, using create a new sprite node for that, and then call setup, which draws the actual building and puts it in. So the rectangle will be the right size, and we say, hey, now you're ready, set up yourself, and it'll do the rest of the drawing code for us. So back in the gamescene.swift file, add this func create buildings. So I start at -15, like I said, so var current x, CG float again, because it's all in SpriteKit like CG float, is -15. So start off the screen to the left. And then we'll say while current x is less than 1024, so while we're still moving left to right, we'll create a new building. So we'll say var size equals CG size. With width, we want to choose random int, and then I said 2 and 4, like I said, and times 40. So I'll choose a width between 80, 120, or 160. Height is truly random, so I'll do random int, and then 300 and 600. So always different height buildings. Then we want to add that position to our current position, so this current x thing. So we'll make our current x move along the width we just made. So we do current x plus equals size.width, oops, I'm in caps, size.width, and like I said, add 2 to that to make a little bit of gap between buildings. Then create a new building node, so let building equals building node. This has got default constructor of color size, so do color UI color.red color, size is size. Then position it at the place, we'll do building.position equals CG point. Now remember, we can't just use the current X here because SpriteKit positions things from the center of the sprite as opposed to the left edge, as we'd expect in UIKit. So instead you have to subtract from current X the half the size, so it centers it on the left edge as we'd expect, making it spaced quite nicely. So do X, current X, minus parenthesis size.width divided by 2. And for Y, we want size.height divided by 2. If you place it at 0, it would half be on the screen, half off the screen, so that just puts it fully on the screen. Then we call the setup method. This is the bit that actually draws it as a building, and add that thing to our scene, and also add it to our buildings array, like that. Boom. Build succeeded. That's quite a lot of code. We haven't run it yet. Let's find out if it actually works. Make sure iPad 2 is chosen. Press play and cross your fingers. Oh yeah. I'll try again. Look at that. Different every time. 3 different building colors, lots of different light configurations. It's all completely random, which is exactly what we want. So the game's different every single time. So like I said, we've got this array of buildings going left to right. So starting at -15 and carrying until we hit the edge. So it's going to hang off the edge here. And we're adding them to an array because we want the first monkey to be appearing on this building at the top, just like in King Kong. And the second monkey to appear in the second to last building. So not this one here, this one. And now you can see why more clearly. If we'd use the last building, it might be hanging off the screen, which is not going to look very good. Second to last one, we're sure is fully on the screen, so it's a much better choice. Either way, it's completely random every time the game plays. So let's take this to the next level. We're going to start mixing UIKit and SpriteKit. Now this is something we've been doing ever since Project 11, our very first SpriteKit project. If you go back there now, you'll see a game view controller Swift in there, which is a boring old UI view controller doing all the work of loading our scene and showing the scene. There's a main.storyboard file in there doing all the work of a view controller again. And what you'll see actually inside the storyboard here is that the type of view, this thing, if you open up the pane on the right and go to the identity inspector, tells you it's actually an SK view, a SpriteKit view, which is a custom class, and that's the view type that holds SK scenes, which of course is our game scene. This has existed all along, but we've basically been ignoring it with no need to use it. Now we do. Because in the game Gorillas, the first monkey says, I want to show throw the banana at 45 degrees angle with strength 150. And you throw the banana and hopefully hit the other monkey. If you do, you win. If you don't, it's the other player's turn, who then enters their own angle and their velocity. That was done by text, which is a bit ugly. We're going to upgrade that to be all iOS by using a UI slider. So we used this back in the core image project, and we'll let people just drag along how high and how strong they want to throw each banana before pressing a launch button that makes the magic happen. We're also going to add UI labels that show the numbers attached to those sliders. Otherwise, the game's extraordinarily hard. Anyway, so if you think about it for a second, what it means is our game view controller needs to house and manage the UI, and the game scene needs to manage everything inside the game. But they must talk to each other. The view controller has to tell the game, hey, fire a banana because launch has been tapped, and here's your angle, here's your velocity. And the game scene needs to say, hey, the turn's finished, go ahead and prepare the UI again to throw another banana. Now you could use NS Notification Center for this. You could post notifications between the view controller and the scene. That's fine, but it's a bit disingenuous. We know exactly what data we want to send and receive. So the easiest solution here is to give the view controller a property that holds the game scene and give the game scene a property that holds the view controller. Now, this is important. Listen very carefully. When you have object A that owns object B and object B that owns object A, you have a strong reference cycle. Neither of them can go away. It's a bad thing. It will destroy your app, so be very, very careful. The solution is to declare one of them as being weak. And it means I want to reference it, but I don't want to own it. So I don't care if the reference goes away. Now in this particular case, the game view controller, this thing, needs to strongly own the game scene, and in fact right now does strongly own the game scene because the view controller owns the SK view and the SK view owns the game scene. So we can have a strong reference from the game view controller to the game scene, and then a weak reference back from the game scene to the game view controller. This is actually very, very easy to do. Inside the game scene, up here, add a new property, which is this weak var view controller colon game view controller exclamation mark. That weak keyword is all it takes to say, listen, I want to reference this thing, but I don't care if it goes away. Let it go away if it needs to. And then inside the game view controller, we haven't been here before, but you'll see class game view controller colon UI view controller. In here, you want to say var current game is a game scene exclamation mark. Not weak var, it isn't required. It can be a strong reference, that's perfectly fine. So, to make that set correctly, inside this viewDidLoad method, there's lots of stuff in here, including, shows FPS and shows node count. You probably want those to be false by now. Just after the call to present scene, we want to set this property. So current game equals scene. So the initial game scene is set to our property, so we can start using it. Now the actual user interface. Go to main.storyboard, and you'll see we have the usual sort of square layout like that, which is okay when you don't have too much design to do, because you're designing the abstract. You can use auto layout to position things correctly. It's all very clever, all very nice, but actually this layout needs to be iPad landscape size screen, which means we want to be able to have an iPad landscape size canvas to draw upon. To do that, we'll turn off size classes. We've done this before once. Go up here to the file inspector, then choose use size classes. It's on by default. Select it now to remove it. It'll say what do you want to keep and choose iPad, then disable size classes. And you'll see a large now iPad portrait size screen, which you want to get to be an iPad landscape size screen. So with the view controller selected, go to the property inspector, attributes inspector, and then choose orientation landscape. And you'll see an iPad landscape size screen ready for us to inflict our genius onto. Using the object library, go ahead and search for slider, and then drop 2 sliders onto your layout. 1, 2. Animate them both using the size inspector, 300 points wide, like that. This first one should be at X20, and this with Y20, and the second one should be at X480, X480, Y20, like that. Boom. Now we're going to add 2 labels to show the value of the sliders. So we'll look for label instead. Drop it in. That. As 1, and there is 2. Both of these should be 120 points wide, so select them both and just type in 120 for the size, the width. The first should be at X325, 325, and then I'll use Y24, which is slightly lower, but it makes it align vertically with the slider. This one's also Y24, and then X value for the second one should be 785, like that. So just next to the sliders, vertically aligned. Then a launch button beyond that. So I'll look for a button in the object library. Drag it out. This needs a width and a height, so width is 100, height's 44. I'll give it X910 and Y13. So it's all vertically aligned with these things. And for its title, I'll write launch, like that, in big letters. I may actually make that a bit brighter, so let's use red text. And there we go, look at that. 22-point font, gorgeous. We also need a label to show who is currently in control of the game. So to do that, place another label and drop onto the screen. This should have X of 370, Y 64, width 285, height 35. Boom. That will show whose turn it is. To make it all perfect, we do have to make a few slight tweaks here. So using the attribute inspector, this thing here, change the left-hand slider, this one. So it's got a maximum value of 90. This will be our angle. And then give it a current value of 45, i.e. half of 90. For the right-hand slider, this will be our velocity slider. You want to give it a maximum value of 250 and a current value of 125, so half of 250. So with that all set up, I can go ahead and add some text here. So let's center that and say, what should we call this? Left, Pulp Fiction bracket, then player 1. Like that. So it's quite clear who is going to control. There's our gorgeous launch button set up. This is pretty much done. We need lots of outlets here. So go to the assistant editor. So let's create some inside the game view controller. So let's grab the first slider, bring him down, call this angle slider. Boom. For the label, get it down and call it angle label. For the second slider, control drag, velocity slider, and then labels, same thing, control drag. It's going to be velocity label. Let's have an outlet for the launch button too. So called launch button. And then this thing here, control drag, outlet's going to be player number. So an outlet for everything on the screen. We also have to create actions for the left slider, the right slider, and the launch button. So find some space in your code down here. There we go. Then control drag from the first slider down. Change outlet to be action. Call it angle changed. Then rinse and repeat for velocity. So control drag down. Outlet for action. Call it velocity changed. And then let's go to the launch button and control drag from there down to here and call this action launch, the actual work part. So the methods for our two sliders are quite simple. They just have to update the label with the right information, whatever is a slider's current value. Now the UI slider, this thing here, only stores its value as a float, which is a bit silly. In our case, we're going to convert that to integer because we don't care about the precise 0.009, whatever it is, value of the thing. We just care as angle 89, 88, 87, whatever. So let's look at angle change. In here, it has to update this label with the angle. So we'll say angle label dot text equals angle colon and then string interpolation. Cast it as an integer. Angle slider dot value, end cast, end interpolation, and you want to add the degrees symbol in here, which is done like that. If you want to find out that key combination, just buy the book. Just kidding. It's Shift Alt 8. Obviously, Shift Alt 8 is a degree symbol, and that's the entire method. It's not even too difficult to do. And then for velocity changed, we'll do velocity label dot text equals velocity. And then again, string interpolation, cast as int, velocity slider dot value, end quote, like that, boom. The only hard thing in there is, of course, typing the symbol, which I've told you what to do, Shift Alt 8. Now let's add calls to angle changed and velocity changed inside the viewDidLoad method, just after the call to super, which will give those text things an initial value. So we'll do angle changed nil, and then velocity changed nil. So they have their initial text values set. Okay, when the player taps the launch button, we want to hide the user interface so they can't fire again until we're ready. So the game scene can go ahead and launch the banana at the current angle with velocity and then do all the physics it wants, do the whole thing, banana flying around, whatever, and only when it's finished with the banana, say, okay, change players. So the code for the launch method is pretty much trivial because it just relies on a method we haven't written yet called launch in their game scene. So we'll say in here, angle slider dot hidden equals true. Get rid of the first bit of UI. Then angle label dot hidden equals true. Then velocity slider dot hidden is true, and then velocity label dot hidden is true, and launch button, launch button dot hidden is true. Easy, 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 easy. The hard bit is calling current game dot launch. We haven't written this yet, so we'll say angle. I'm kind of making this up now. Cast as integer angle slider dot value, comma velocity is again cast as integer velocity slider dot value end end. That's going to call a method called launch, passing in parameter angle and parameter velocity. Finally, we're going to create a new method in here called setPlayerNumber that will be called from the game scene back to the view controller when control should pass to the other player. This will just update this label here, player 1, to show who's in control and show all these controls again, unhide these things. So we have func setPlayerNumber number int if number is 1, we're going to say player number dot text equals left Pulp Fiction bracket player 1, else player number dot text equals player 2, and then right Pulp Fiction bracket. And then let's just unhide all these things. So just copy and paste all this text and paste it down here and change true to be false, 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 false. Re-show the user interface basically. Now to make your game compile, you must have this launch method. So in gamescene.swift, boom, go back to standard editor, just create a dummy launch method. So we'll say func launch hash angle or octothorpe angle, depending what kind of mood you're in, then velocity int. Remember the hash # octothorpe is required to force that first parameter to have a label. That's it for now. So your code compiles again, but this is where it starts to get serious coding. We're going to fill in this launch method. First things first though, before we launch any bananas, we actually need to have some players to launch bananas. This isn't too hard, so this needs to create a player. It needs to create a physics body that lets it collide with bananas. Make it not dynamic so it doesn't move around in the game. Position at the first player at the top of the second building in the array, add it to the scene, and then do the same thing for player 2, except on the second to last building. I'm going to use circle physics here because the monkey graphics we're using, look in here, they're kind of circular. Not perfectly, but close enough. And it's a shortcut. You're using pixel perfect for everything isn't ideal. So to add the player to the top of a skyscraper, we just have to add the player's height to the building's height and divide by 2, because everything's off from the center. Then add that to the building's y coordinate and it's done. So first up, let's create properties for the players. So we'll say var player 1 is an SKSprite node. Var player 2 is an SKSprite node. And then let's make a banana while we're here, SKSprite node. And our current player is 1 like that. So we have create buildings. Let's have a create players method. So func create players. So player 1 is an SKSprite node. The image name, what did I call it? I called it player. Player, like that. Then we'll name him player1.name is player1. Give it a physics body that's circular, so player1.physicsBody equals sk physics body circle of radius, and we're just going to use player1.size.width divided by 2. Then player1.physicsBody .category bit mask, what kind of thing it is for physics purposes, is collision types .player .raw value. Then player1.physicsBody .collision bit mask, what should it collide with in the game, as in bounce off, equals collision types .banana .raw value. And actually that line should also be the contact test bit mask. Contact test bit mask like that. Finally, make the player non-dynamic, so player1.physicsBody.dynamic equals false. Like that. Let's position him at the top of the second building in our array. So let player1 building equals buildings1. because they are 0 based arrays. Then player1.position equals, this is a bit of math tip but not a lot, CG point. We know we want to put it, X, we want to put it at the player1 building.position.x, so the center of the building. But we want to say, take the building's Y position, so its current height, this is player1 building.position.y, and add half of its height and half of the player's height. So we'll say player1 building.size.height plus player1.size.height, and then divide that by 2. So let's put another bracket here so it's a bit clearer what I'm trying to do. Let's hide some of these panes so you can see what I'm doing. And divide that by 2, then end it like that. Boom. So this thing will be, so if you imagine a building that's 256 up by a height, like this, so the height, forget the width, so it's 256 high. This thing will report a Y of 128, half of 256, everything's measured from the center. So if the whole height is 256, Y will be 128. This thing will be the full size of 256, but we want to get half of that, so it's 128. This will tell us the height, the top edge of the building. We want to add to that half of the player's height, so the player is looking like they're sitting on top of the building like that. That's what this code here is doing. And then add that to our game scene, player 1. Player 2 is very, very simple. Just copy and paste this code basically. We'll just monkey it slightly. Monkey it. We'll do player 2, player 2, player 2, 2, 2, 2, 2, player 2 building, player 2, then player 2. So all these 1s become 2s. I'll almost certainly miss one, but you know, that's my life. Player 2, player 2, player 2. Oops, 2. Great. I think that's all of them. Oh, there's a name missing there. Boom. It's the same stuff. We want to change buildings 1. That will no longer be correct. We want to see the second to last one. So we'll do buildings.count -2, like that. So second to last building. Otherwise, oops daisy. Otherwise, it's fine. I'm getting a complaint because it doesn't like us passing in any object. Yeah, that's not helpful. You can actually zap these and put in UI slider like that, and that should be hopefully like that. That is indeed much nicer. UI slider. It's just whinging because any object has to be an actual object, and nil is not an actual object. It has to be force unwrapped like we're doing there. A minor tweak. Right, so that makes the code compile again. You could actually, if you wanted to, leave it as any object, just use exclamation mark like that. You know, whatever. Yeah, I think, yeah, that's nicer. That's nicer for now. We're not using the value anyway, so it's not too important. Anyway, back to our code. So create player 1, add the physics, put it on top of the first building, or second building, sorry. Same for player 2, just a second to last building. That should hopefully create the monkey successfully. You just need to call this thing in the right position in the did move to view method. So before we do that, we have to actually get these pictures, because I said at the beginning of the project, do not copy in the pictures from the project. So there is no monkey picture. Player over here is not in the project right now. And before, what you do is you just go into Finder, you'd select your pictures and just drag them all in. You could do that. You could use image catalogs. That's fine too. This time we're going to use a different thing, a special thing for SpriteKit that's even more optimized than image catalogs, asset catalogs, sorry. And they're called texture atlases. Now what this does is it kind of stitches together all your pictures into one big picture and then optimizes the loading of that so it loads faster, and it uses that same picture for every sprite, essentially cropping it and moving it around so it looks like different pictures are being used. The only way to really describe this to you is to show it to you, because it really it's very strange but very cool. So to make that atlas, go ahead and find your project files here, open it up, and make a new directory in there. And this should be called assets.atlas. This part, assets, could be anything you want to. The .atlas is important. That means it's a texture atlas. And in there, I'd like to copy all the files from the content folder except for the SKS files. These are two explosion particle systems that we can't put inside a texture atlas, but everything else can go inside. So grab those, copy them across to the atlas, and then copy that atlas into your Xcode directory. So just drag that into Xcode, like boom. Yes, all default settings are fine. You also want these two SKS files dragged in separately. They're the explosions. Anyway, everybody's good. There is fine. So that almost makes everything work. All you need to do now is call this create players method from somewhere. So after you say create buildings, call create players. Boom. That at this point should, I believe, work. So press play. Let's see where we are. Oh, look at that. There's our gorgeous UI at the top, and there's monkey 1 and monkey 2 being loaded from a texture atlas. Now, the only way to explain how these things, like I said, how they work is to show it to you. So choose from up here iOS device. This thing's red, hasn't built the actual product. Choose iOS device and press build again, and it will build the product down here, the .app file, the finished built bundle thing for us to look at. And when it finishes building, take its time. Right click and choose show in Finder. So right click on this app file, choose show in Finder, and here it is here, along with some other junk. Right click on that file and choose show package contents, and you'll see assets.atlas.c, the compiled texture atlas, and look what it's done. So it's taken the monkey pictures and added them to one picture along with the banana. One big picture has all three monkey textures inside, at 2x and at 1x. Automatically. It's an extremely efficient way of doing it. And it creates a plist for it as well, describing the offsets of every picture. So here it's, this is a coordinates. Is it rotated? No, it's not. One of them was though. I'm sure I saw a monkey being rotated somewhere. There he is. This one is rotated. So it actually rotates the textures as well to make them use the best space as they can, least space, so the texture loads the fastest. Texture atlases are the most efficient way to draw things inside your SpriteKit game. And here, it's perfect for our various pictures of the monkey. You don't have to change your code. That's the magic of them. You can use asset catalogs, you can use straight raw files inside your bundle, or you can use texture atlases, and the code is identical. It's such a wonderful, wonderful iOS feature. Okay, so we now have in our game random sized buildings, two monkeys on the second building and second to last building, plus some user interface. We can just drag this around and hopefully it'll update. There we go, look at that, magic. Plus a launch button that hides everything, and then otherwise nothing else. So it's time to make that launch method do something interesting. This is going to be a complicated method, so listen carefully. It first needs to figure out how hard to throw the banana. Now we accept as part of our method call a velocity and an angle, and the combination lets us decide the angle and the velocity to throw it at. It's not as simple as saying 90 degrees, because you have to calculate what that means in a velocity for x and y, not just an angle. So it is complicated, but I'll walk you through it as best I can. The way to do it is to have a special fixed formula that converts degrees to radians. Now this is not included as standard inside SpriteKit, but I'll give you one now. It's quite straightforward. You say func deg to rad degrees int return double. This is because our slider at the top here, which has gone away because I'm currently writing some code, 29, this accepts degrees, and we need radians because everything works in radians inside UIKit and SpriteKit. But of course, users don't care about radians, they care about degrees. So we have to accept degrees and convert to radians. This is this deg to rad method here. So the formula to convert from degrees to radians is return double degrees times pi divided by 180.0, like that. That'll take this degrees and return that same number in radians. So next up, I want to introduce you to how we throw the banana, how we know the right physics to apply. This is going to use a new physics property called uses precise collision detection. This is a different thing. We haven't seen it before. And it's used if you have small, fast-moving objects. Because what happens with SpriteKit is every frame, 1/60th of a second, it says, okay, move everything forward, are you colliding with anything now? Next frame, move everything forward, are you colliding with anything now? And so forth. The problem is, with small, fast-moving things, they can pass through something they're supposed to collide with in just one frame. You know, you've got a banana, it might actually whiz past a monkey in just one frame because they're both fairly small. As a result, the collision won't happen. And if you ask for precise collision detection, then SpriteKit does more work. It actually kind of draws the velocity of the thing and simulates a line. It was here, move it along the line, checking for collisions along the way. So it's slower. Fortunately, SpriteKit is extremely optimized, so it's actually quite fast for us to use. Question is, how do we know which direction to throw the banana in? This is not a book about trigonometry, so I'm going to use words and assume you understand them. And those words are sine and cosine. And if you did well at maths at school, you'll be happy here. If not, you may struggle. Just copy my text and move on. So the answer is quite simple. If we calculate the cosine of our angle in radians, then it will tell us how much horizontal momentum to apply. And if we get the sine of our angle in radians, it'll tell us how much vertical momentum to apply. And once that's calculated, we just multiply it by the velocity that's passed in, or in the case of player 2, negative velocity, so we want to throw to the left, to make a CG vector, and use that to propel the banana in the right direction. So, figure out how hard to throw a banana. We accept the velocity, but I'm going to modify that just slightly. Again, you can playtest yourself and do what you want with that number. Convert our angle to radians. As a check, if there is a banana already, remove it and create a new one, but there shouldn't be one already, let's face it. If player 1 was throwing the banana, we're going to position the banana up and to the left of the player and give it some spin. This is actually away from the player, so the player can't kill themselves very easily. They have to work quite hard to kill themselves. Then make player 1 animate throwing the arm and put it down again. You'll see if you look at the texture atlas, you'll see there is a up arm and a regular monkey picture. It'll flick up and down again. Make the banana move in the right direction, and then if it's player 2 doing that, do the opposite. So animate him, throw the banana on the opposite side, give it the opposite spin, and so forth. So here we go. Time for the complicated launch code, and it is complicated to be fair. First up, I'm going to say var speed, how hard to throw the banana, equals double velocity divided by 10. So the velocity comes in at something like 250. That's so users have got a lot of control over their velocity. I've divided that here based on just me testing the game again and again and again. I think divided by 10 is about right. By all means, you play it and figure out what works for you. Then convert our radians, so our angle here, our angle in degrees into radians. So let radians equals deg to rad angle. So we now know the angle and velocity to throw the thing at. If there is a banana already, if banana is not nil, then banana remove from parent. Oops, banana dot remove from parent. No, remove from, I need some coffee. Remove from parent. And then banana's nil, just in case it did exist. Then create a new one. Whoops. Then create a new one. Banana equals sk sprite node. Image named banana. Give it a name, which is banana.name is banana. Give it a physics body. Physics body is sk physics body. I'll use circle physics, it's perfectly fine. Banana.size.width divided by 2. Then give it a category bit mask so we know what kind of physics object it is. So physics body.category bit mask equals collision types. Collision types dot banana dot raw value. Then tell it what to bounce off. Dot collision bit mask, and it should bounce off buildings. So collision types dot building dot raw value, or collision types dot player dot raw value. So either buildings or players should collide with the bananas. Then say banana dot physics body dot contact test bit mask, which things we want to be notified about, is the same thing actually. So just copy and paste that text. Boom. Then enable the new property, uses precise collision detection to be true, and add that to our scene, like that. Now, We have to apply the right, nil, literal convertible, just nil's fine, thank you. Ignore that, it should be nil. Now to apply the right direction and angular velocity, the spin to the thing, depending on who threw the banana. So we'll say if current player is 1, then banana.position equals CG point, so up and to the left of the player. So we'll do player1.position.x minus 30. Y is player1.position.y plus 40, like that, so up and to the left. Banana.physicsBody.angular velocity, some sort of spin for the thing, equals minus 20, make it spin as it's being thrown. Then animate it throwing its banana. You'll see there are 2 arms, one for the left player throwing that way and one for the right player throwing this way. We'll load the right one, so we'll do let raise arm equals skaction.setTexture, skTexture, image named player1 throw. That. These names, by the way, are coming from the original Atlas selection here. They get removed, of course, because they end up being one big picture, but inside the plist you'll see these names are preserved. So you see it has aliases here for all these things and then sprite offsets, and you'll see player1 throws right here. So that will say use the throwing arm, then we'll lower the arm again, so let lower arm equals skaction.setTexture, skTexture, image named, just player again, regular monkey picture. We're going to pause between raising and lowering, so we'll say let pause equals skaction.wait for duration, 0.15. So wait for a 15th of a second. And queue up that as a sequence. So that sequence equals skaction.sequence. It's an array, so what is it? Raise arm, pause, lower arm. So you get a nice little animation, and then run that for player1 sequence, like that. The right direction to throw the banana happens to be, so we'll do let impulse equals CG vector, dx. So dx should be the cosine of our angle in radians times the speed that we calculated earlier, which is just the velocity divided by 10. And the distance to the y should be the sine of our angle in radians, times speed, like that. And we're going to say to the banana, physics body, apply impulse. This pushes the banana in a certain direction, as if it was sort of literally thrown. So we'll say our impulse, like that. Now you can copy and paste all this text in here under this else block, else, like that. This is for player 2. So the banana's position should not be up and to the left, that will kill the player. It needs to be up and to the right, like that. It needs to have a different angular velocity. It's just normal 20, no, rather than minus 20, because it needs to spin the other way. It should be player 2 throw for the raise arm action, not player 1 throw. And then finally we say player 2 run action, that thing. For the impulse to apply, we need to use minus speed for dx, because we're going left to right rather than right to left. Other than that, the game is actually coming together. We can hopefully press build now. It is whinging. I missed off X there, and I missed an X there. That's straightforward to fix. Let's go back to iPad 2 rather than device. Come on, you can build. That's it. Run that back. Let's see if we're getting somewhere here. So I'll press launch. Oh, look at that. Fantastic. So the banana hit the building and sort of rolled around. Bit of an anticlimax. That's okay. The bananas don't explode. Of course, player 2 never actually gets a go, which is a bit of a shame. But we're getting there. Next up, the most challenging part of our project. Now, as per usual, I've tried to simplify this, keep it as simple as possible. That's the mantra of this course. The easiest way to get a result here without learning tons of algorithms is to create destructible terrain by modifying our building image again and again and again. Step 1, we need to be able to have collision messages sent to us. And that means going into did move to view up here, and somewhere in there, doesn't matter where, saying physics world dot contact delegate equals self. Tell us when there's been a contact. You will need to, of course, make this scene conform to the SK physics contact delegate protocol, like that. Now, when it comes to did begin contact, there are various possible contexts to consider. Banana hit building, building hit banana, the usual sort of philosophical problem we have. Banana hit player 1 hit banana hit player 2, and player 2 hit banana. There's a lot to check. So we're going to eliminate half of them using a very simple technique. Because if you look at the enum we defined, it's got banana building player 1, 2, 4. This is ordered alphabetically, and this is ordered numerically. And with that, we can do a little hack to eliminate half the checks. What we can do is we can say, declare 2 new variables of type skPhysicsBody and assign 1 object from the collision to each. The first body will contain the lowest number, and the second body will contain the highest number, which means if banana, number 1, collides with building, number 2, we put banana in the first node and building in the second one. If building collides with banana, the same thing happens, so we eliminate half the checks, which is very, very nice. We're also going to conditionally unwrap both the bodies. They're optional because they might be nil, and in our case, it's actually very likely, because if we get banana hit building as well as building hit banana, one after the other, we have to make sure we check that the values are not nil, because the first one will remove the banana from the game. So it'll be nil the second time it comes around, so we have to be very, very careful with that. If the banana hit a player, we'll just call a method called destroyPlayer, which I'll fill in briefly later on. If it hits a building, we'll call banana hit building, which will also be done later. But that will also pass in the contact point where the banana hit the building into the method. So that's all you need to know for now. Go ahead and start writing did begin contact. So func did begin contact, like that. So we'll do our little hack here to figure out which thing collided with which other thing. So we'll do var first body is an skPhysics body, and var second body is an skPhysics body, like that. And we'll say compare the numbers of the two to figure out which one's the lower one. So we can say if contact.bodyA.categoryBitMask is less than contact.bodyB.categoryBitMask, then first body is contact.bodyA, second body is contact.bodyB, that, and then just reverse it in here. Body B, body A. So it doesn't matter whether banana hit building or building hit banana. What will happen is this thing, the first thing, in this case banana, less than the bitmask for building? Yes, it is. So banana goes in here, building goes in here. If we get building hit banana, other way around, it will come out as false. So banana goes here and building goes here. So the same result happens. So either way, first body will be banana, second body building, or first body building, second body player. So it's a simple way of halving the number of calculations to do. So we're going to unwrap both these bodies to make sure we have something in here that is safe. So we'll say if let first node equals first body dot node, and if let second node equals second body dot node. So we now have definitely 2 nodes here ready to work with. So we can say is the first one named banana, and second node, name is building. So this is banana hit building. So we can call a method here banana hit building. Pass in the building that was hit. So do second node as building node, and then at point contact.contact point as passed in as a parameter to this method. So the location it was hit, which building was hit. After that, we'll do if first node.name is banana and second node.name is player 1. Then we want to do destroy player 1. Copy and paste that for player 2, player 2, player 2, like that. So that's the sort of core of did begin contact done. We have to do, obviously the banana hit building method needs to be written, and destroy player should be written. And ideally, if the player has been destroyed, we want the game to continue with a fresh game, which is, again, something we haven't tackled yet. This is the last project for SpriteKit. Let's go all out and do something really, really cool. We want to transition between scenes using an SK transition call. This is really easy to do. We're going to have a new method down here, func destroy player. Player is, of course, an SK sprite node, like that. First up, create an explosion where the player was. Straightforward enough. We do let explosion path equals ns_bundle.main bundle.path for resource. I've called it hit player. Of type is SKS. I've chosen indirect of accident, it's not required. Then let explosion equals ns keyed unarchiver dot unarchive object with file explosion path typecast as sk emitter node. Position it where the player was. Add it to the scene. Like that. Then remove the player from the game. Remove from parent. Actually remove the banana too. Banana dot remove from parent. That actually is actually optional, like that. So that removes the banana from the scene and the player from the scene. Now comes the SK transition. Start a new game smoothly and animated. So we'll say run after delay, 2 seconds, unowned self in. Create a new game. So let new game equals game scene. This will take a size. So let's do our current size. Actually, you do self in there, self.size, like that. Then we need to do a little bit of work to assign its view controller property. That's this thing up here. Remember, the game scene has a handle to the view controller, and the view controller has a handle back to the game scene. We need to modify both here. So we'll do new game.viewController equals self.viewController. And update the view controller's game scene as well. So self.viewController viewController.current game equals the new one, like that. We'll also call self.changePlayer, which isn't written yet. I'll come back to it in a second. So that if player 1 destroyed player 2, next time player 2 gets the first throw. The actual magic here, the real work that we want to do is to move a new, show a new game scene, is to say let transition equals sk transition dot doorway with duration. There are quite a few of these. This one's particularly nice, I think. 1.5 second doorway duration. And we'll do self.view.present scene new game with a transition of transition, like that. Okay. There are quite a few errors here, but that's okay. That's okay. I'll get that in a second. That should be in, not in it. Otherwise, it's looking good. The change player method is super trivial. Let's do that now. So this should be, hello. I'm missing an ending brace there, but that's why it's complaining. Good. This needs to say func change player. If current player is 1, then current player is 2. Else current player is 1. Deeply exciting. And then call the view controller's set player number method with the new player number, like that. So it updates itself with the right text. It's still complaining because we haven't got banana hit building yet, and we haven't got func. That's Xcode's code completion going a bit nuts. We haven't got banana hit building yet, so we'll do that now. This isn't too hard because it's going to do most of the work inside another method. Just pushing code around, really, just creating methods that call other methods at this point. But it's coming together very soon, don't worry. So banana hit building is trivial because it doesn't do much work. So let's do func banana hit building. Building is a building node, and we have at point, contact point, CG point. So remember, this is the external parameter name, internal parameter name. So they say at point, we reference contact point. So what we have to do is, this is telling us where the bananas hit the building, but it's doing it at the SpriteKit scene level. We want to know where on the building we were hit. And that's done by converting the point from us, the scene, to the building. So we'll do let building location equals convert point. You want from node, or two nodes are like that one there. So the point to convert is the contact point. To node is the building where it was hit. And then we can say building.hit at point and then building location. That's another method I haven't written yet. Again, like I say, I'm just pushing code around realistically. Then we'll say let explosion path equals ns bundle dot main bundle dot path for resource hit building of type SKS. I keep having indirectly for some reason. Force unwrap, then load it let explosion equals ns keyed unarchiver dot unarchive object with path explosion path add sk emitter node, then position it correctly. Explosion.position equals contact point. Add that to the scene, like that. Remove the banana from the scene if possible, if necessary, and destroy it. And call change player again. No matter what, we call change player. The only new thing in that whole chunk of code is convert point. That's a 5 come in your Swift learning, by the way. You know so much now. I can just type and you should hopefully understand as you pause and unpause. So convert point is the only thing that's new, and that converts the scene coordinate to a building coordinate, which means, for example, if the building was x200 and the collision was x250, that would return x50 because it's 50 points into the building node. And now for the part where we just handle destroying chunks of the building. With your current core graphics knowledge, this is something you could do only by learning one new thing, which are blend modes. We haven't covered these with core graphics before, but there are a few of them and they affect the way you draw things onto the screen. And one of them is called KCG Blend Mode Clear, and it effectively lets you cut holes in graphics. And that's how we're going to do our destructible terrain. We'll find out where it was hit. We'll create a rectangular or a elliptical path around where it's hit, and then draw that path with a clear blend mode so it gets wiped out completely. So choose your building node, there it is, and add this new method, func hit at point. It must take a parameter for the point, so we'll do point is CG point, like that. So keep in mind that core graphics and SpriteKit do not work with the same coordinate system. Specifically, core graphics counts from the bottom left corner of the screen being 0, 0, whereas SpriteKit counts from the center horizontally and vertically being the position of the object. So you have to convert between the two. This is not very hard to do. A little tiny bit of maths. We'll do var converted point equals CG point. And what's an x? So x is point.x plus size.width divided by 2. And y should be abs, i.e. make negative numbers positive. Abs should be point.y minus parenthesis size.height divided by 2. Parenthesis, 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 like that. That converts a point from SpriteKit coordinates to CG color coordinates. So we can say UI graphics begin image context with our current size. Actually, we should use context with options. Sorry, context with options. Our current size, opaque false, scale is 0, so make it retina automatically. Let context equals UI graphics, and then you want get image, get current context. Then, this is where it gets interesting. We're going to draw our current building picture into our new context. So we'll say current image dot draw at point, and then it was a CG point, so we'll do CG point, X is 0, Y is 0. Just draw the current building sprite in there. And we're going to add an ellipse there that signifies where it's been hit. So we'll do CG context, add context, add ellipse in rect. Context for the thing. The rect should be CG rect use one with X and Y, like that. The X should be converted point dot X minus 32, i.e. center it. And then converted point dot Y minus 32. And then for width, we want 64 and 64. So if you imagine the banana flies in and hits this X here, we want to move up and left 16 points and draw 32 points. Oh, sorry, move up left 32 points, draw 64 points. So up and left here 32 points, draw 64. So it centers it on the impact point quite nicely. So that adds the ellipse to the path. We're now going to use a CG context set blend mode, how to draw this thing. And we'll do context, and it should be KCG blend mode clear. Destroy whatever's there already. It literally leaves a hole where it was there. And then say CG context draw path context, and we'll use KCG path fill, like that. So it fills in this zapped area of the banana. Then we want to pull out the image of that thing. So let image equals UI graphics, get image from current context, and then do UI graphics end image context. This now needs to update the texture. We've hit the building, it's been redrawn with a hole in, redraw our current texture. So we'll do self.texture equals skTexture with image img. And also update our current image property to be img. So next time when we draw it in again, we have the destroyed version being drawn in. So over time it gets more and more destroyed. And then call configure physics again. Pixel perfect collision detection will have changed by now. There's a hole in the building. This will mark that hole as being not hittable. One curious thing about SpriteKit is when it does this fast pixel perfect collision, if you manage to chop a building in two with lots of bananas, which is actually quite hard to do, only one half will respond to physics. Important proviso. Now there is just one more thing to do before the game is finished. Now, what happens if the banana misses the other player, and in fact misses all the buildings as well? Right now nothing, the banana goes off the screen and just falls and falls and falls forevermore, which is not good enough. We're going to fix this by using the update method. If the banana is way off the screen, remove it and change players. So look for the update stub method we had before inside gamescene.swift. Update is, for me, there it is. We're going to say if we have a banana and the banana's position Y value is less than minus 1000, so way off screen, then banana remove from parent, remove from parent, banana is nil, and change player like that. End brace, end brace, end brace. I put a space in there by accident, minus 1000. And that's it, it seems to run. The game is actually finished now. I know it's been quite a lot of code, but hopefully we now have a working game. I'll press play. Here's the first monkey. I'll press launch. Oh, it's crashed here. And it's crashed because we are not setting the view controller. So we're calling change player, and we are not setting the view controller. So if you remember, we have the game scene owns a property to the view controller, and the view controller owns a property to the game scene, and we must make sure these are set correctly. Otherwise, you get this problem here, which is we're calling this thing is currently nil, and it needs to not be nil if possible. So to do that, we want to give it an initial value somewhere, and you can do that easily enough inside game viewcontroller.swift. You can just assign it here. So when we're creating the thing, you can say here scene.viewcontroller equals self. That'll be good enough. Press play. Let's see if it works any better. Launch. Boom. Hole pulled out the building. Fantastic. Next player. Oh, that's a little bit of a bug there, wasn't it? Player one's always throwing. Look, I've made a slight mistake in my code. You love my mistakes, I'm sure you do. Let's look for the launch method. Here it is, launch method. We are creating the banana at player one position. I missed the player one. Dumb. Let's try that again. Run it back. Throw. Didn't. Oh, I see. There's a slight glitch here. If you hit two buildings, it gets confused and changes player twice. It's wrong. By all means, you can fix that in your own code. So you can see I'm just carving holes in the building so far. I'm going to try and update my velocity slightly more to throw a bit harder. Oh, missed him just. First one, got him. Boom. And look at that doorway transition. Player 2 starts the game. Or player 1 starts the game. That's another bug you can fix in your own code. I'm not going to fix that for you. That's a very trivial bug to fix. So, that's the game finished. I hope you think it's impressive because we have done quite a lot. There's a fair amount of code in here, I think. It's not a short project. I mean, there's what, 220 in there, you know, with some line breaks and stuff. Then there's a little bit inside the building node, which is another 100 or so. So there's about 300 something lines of code, which is a fair amount of code. But a lot of that is all this core graphics drawing. And I think it's all worth it because you've learned quite a lot. I mean, the Destructible Terrain, I think, is very, very nice. And hopefully you've also learned about things like hue, saturation, brightness, and well, more. There's lots of things going on with SpriteKit and UIKit. Hopefully that has gone out with a bang for the UIKit SpriteKit project collection. That's the last creation of games in this entire series. I hope you've enjoyed it. The game is yours now. Please go ahead and add some better graphics. Go ahead and fix the bugs. I do suggest at the very least you say when a banana collides like this, figure out all the buildings it should have exploded next to and remove the full circle. That is not too hard to do, but I do leave it to you to figure it out. For more information, see the website, hackingwithswift.com. Actually, no. I'm not going to leave this project in place with 3 glaring bugs. 1 glaring bug maybe, you can go ahead and fix it yourself, but not 3. To recap, we have 3 bugs right now, and they're so annoying, I have to get rid of them. I couldn't live with myself giving you so many bugs to fix. The first problem is that if a banana hits a building dead on with another building, so it hits 2 buildings simultaneously, not easy to do, but possible, then what happens is banana hit building down here gets called twice, and therefore change player gets hit twice. So the first player gets 2 shots basically, which is not fair. And the second problem is when the player is destroyed, when a player is destroyed, it doesn't hand over control to the other player correctly. It looks wrong. So player 1 gets another go, or player 2 gets another go, depending on who won. The third problem is that when a banana hits a building, it does not destroy nearby buildings, which it should do. That last bug is for you to fix. I'll leave that to you. I'll look at the first 2 and help you fix those. They are very, very trivial. When working with bugs, it's helpful to find a situation that repeats itself easily, so you can be sure it's definitely fixed. And in our case, the easiest way to do that is to make it say random int 3, random max is 3 for width, and then for height, just do 300, 300. So always generates the same sized buildings every single time. So we can be sure we fixed the bug, so we can test with a fixed velocity every time. So I'll try tossing a banana. Okay, as I hit only 1 building, so I'll just lower the velocity just slightly. But it's the same layout of buildings, so this will work quite nicely. So I'll just go to velocity 122 perhaps. Boom. Hits 2 buildings with 1 banana. If I press launch again, the first monkey throws again, which is the bug. Let's fix that. Super simple. Down here in destroy, or banana hit building, sorry, here it is. Just make it not a banana anymore. Say banana.name is empty. This will stop our did begin contact method from finding it. This stuff here will not trigger anymore. So to repeat in banana hit building, just do banana name equals blank. Press play again, make sure the bug has been fixed. So it's velocity 122. 22. Yeah, nice repeatable situation. That and launch. Perfect. Only 1 building. The explosion bug is for you to fix. You can look at that. It's not very hard. The other bug was that if we hit the player, then they don't hand over control correctly. So let's try again. Make we reproduce that. It's a bit stronger, isn't it? 154 perhaps. Nope. A bit harder again. You'll notice I'm doing a fresh run of the app each time, so we know it's a clean slate. 161. Got him. So that was player 1 killing player 2. It now says player 2's in control. Press launch, and it isn't the case. So to fix that, this is another simple bug. Here's where we hand over to the new level inside destroy player. We change the player here And this is actually, if you look, we create a game scene which will have its own current player variable. Then we change our player, but don't change the game scene's current player. Now we can't just call new game.change player because we don't know who did the kill here, so we can't just switch because it may be correct. The solution is simpler than that. The solution is just to say after self-change player, new game.current player equals self.current player. The self being required because we are in a closure here. Build that, run that. So let's try the first bug again. 120, oops, 122. Very precise, but worth being sure. Launch, beautiful. And the second one was 161, I think. let's try 162. So player 2 killed player 1. Player 1 is now in control, like that. So it worked correctly. I'll just try one last time, make sure it all works. So drag up to 161, and then launch player 1. Boom. It claims player 2 is in control, and player 2 is in control. Perfect. Obviously, the velocity 161 always works now because the buildings are all the same height and width. So let's change that back to be fully random again by going up to the generation code for buildings, saying you are 2 to 4 and you are 3 to 6. Press build and run. That now is the new finished project. It is still not perfect. Remember, there's this bug to fix where collisions don't destroy nearby buildings. So if a banana explodes here, it should take a chunk out of this little green building, this little tiny chunk here. And that is not happening right now because we're going to take chunks out of buildings that have been touched directly by the banana. That is your bug to fix. It's not hard and it's easily fixed. What you have to do is make sure that when you hit a building, you look for the building to the left and to the right and see what its position is and call it to hit a point there as well. And this is so simple. I shouldn't have to do this really with you, but at least just look for the convert point method again, which is already, and then hit at point for that thing. Do it yourself. Don't create an explosion there because it'll look strange, but just take a chunk out. It should be absolutely fine. That is your bug to fix. I fixed the first two for you. My guilty conscience would not let me rest. The rest for you, so it's now down to you. That ends the project for real this time. For more information, see the website, hackingwithswift.com, where you can buy this video, including this extra little take at the end, in high resolution. It looks fantastic. Or as downloadable ebooks, which contain lots more information. Alternatively, find me on Twitter. I am at 2straws. If you have problems, questions, suggestions, feedback, whatever, you want to let me know the amazing way you fixed this final bug, do follow me there and get in touch. I would love to hear from you.